So, hi everyone. In this video lecture, we will see how a Google Call laboratory can be used for GPU programming. So, it will be useful for the workshop also. So, the steps that you have to follow are like in first you have to uh, log into Google Colab with your Gmail ID. It could be either your your institute has a Gmail ID, then it can be used. Otherwise, your own personal email ID. Then you have to use the GPU accelerator using the GUI interface provided by the Google Call laboratory. Then we will have a tour of the GUI interface. Then you have to install GCC 10, because if you want to run OpenMP 5.0, you require GCC 10. So you have to install it. Then you have to use CUDA 10. Why I put not install is already in the Google Call laboratory there is CUDA 10, CUDA 10.1, and CUDA 11. We need CUDA 10 for GCC 10 plus CUDA 10 is a combination for OpenMP 5.0. Then we will see some examples compiling an OpenMP program with can be run on a GPU. The execution will run on GPU, and we can profile whether execution is actually happening on GPU using the command npprof. And at the end of this after this presentation is done, we will see exact demo like how it is done using the notebook Google Call laboratory. I'll be running a demo. So to get started, you have to go to the website, open a Google Chrome browser, and you type this URL you type, then you will have this sign in option button. You have to sign in using your email ID, Gmail ID, and once you log in, then you have to create a new notebook. You will have this new notebook you create. Then in that notebook, once you have that notebook, it will be like having an extension IPYNB. It would be untitled 0 or untitled 1. First file. Then you click on edit notebook setting, and then you have to change the device from none to GPU. So you have an hardware accelerator, that is GPU. So select GPU in the hardware accelerator and using the drop down menu, then you click on save. So that is up to selecting the GPU accelerator. Then you can have a look at this interface. Like you will have some folder icon here, X content, that is like see your files in the current session. Then you want to insert some code segment, you can press on this plus code, you will get this code segment button, and you can delete the code segment also. Then code segment is actually like a command line prompt where you can type any Linux or Unix commands. Then write files, etc. is possible with the command line interface. And you can also delete code cell. These options you can look like how much RAM is used, how much disk is used, those details will be like. So RAM is like only 0.81 GB is used out of 12 GB. Disk is like 35 GB out of 64.4. Like there's a Unix already running on this. On top of it, there's a GUI interface. So when you type commands in the code cell, it should be preceded by this symbol explanatory mark. So if you look at alias, when you type this ls/user/local CUDA, it's a shell command, you find that these are the files available. By default, it will be CUDA 11. So then you want to create a file, you type this percentage write file. It's another code cell, now with devices.c, where we have this code. So type the file, then you click on this button using the arrow, this presentation. So copy pasted image. Once you click on it on actual code shell, you will get this num devices.c coming, this folder. So that's about. So if you want to run OpenMP 5.0 programs, which has support for GPU programming, and you want to run GPU programming using OpenMP, that you install GCC 10. So for that, you have to first type in a code cell this command. It will give some, it will do some installation. Then you this will do the actual installation. Like GCC10, G++10, GCC10 offload and vptx libgmp1. This is required for OpenMP 5.0 to work along with the CUDA, so that the GPU, the execution actually happens on the GPU. So if you look at this ls-l/user/local CUDA, you can find that it's already pointing to CUDA 11. But CUDA 11 and G++10 or GCC10 will not work. So you have to modify to CUDA 10 or CUDA 10.0 that is already available in the Google Colab, so you don't have to install it. So you can relink the local CUDA to CUDA 10. So now you will get output like this, that CUDA is now CUDA 10. Once you are done, you can compile an OpenMP program with offloading support. You have a sample program here, and you have written first.c here. Then you have to compile with these command line arguments. What are these exact meanings of this command line argument? We will see during workshop. So once you have minus of first means, instead of executable, will be having an a first. So that is created here, executable. This is a source program. Then you run it with nvprof./first means till you say that there is GPU activities. There is CUDA copying data from host to device, device to host happening. These functions are called. That means execution actually happens on the GPU. So like here in the program, like there is map2 means you are mapping the arrays A and B to GPU, and map from C means you are copying C value from CPU after this at the end of this block. So after computation is done, C is actually copied back to CPU. This is a simple presentation on how it can be used. We'll now go to a actual demo. So here I have already typed all the commands that is required, like writing a now device.c like this. Then you are creating this tool chains, apt install, then you're linking the CUDA to CUDA 10, installing this writing this numdevice.c. You can run like that is this file, then you run it, then you write the first.c, then you compile it, then you run first./first and nvprof.first. So this already I typed in the interest of time. So we'll do one by one. So I'm writing this file. So I'm clicking this actually demo, not the presentation. As you can see, the file name is untitled1.ipanb. So I'm running this command. I just typed it, not executed. So run this. As you say, the shortcut is Control Enter, keyboard shortcut. So Control plus Enter. So once I write it, you can see that the file have come here. Now we are trying to install this GCC10. So for that you have to add a repository for GCC10, and you're adding it. So when this is done now, and where is GCC10? It's actually searching. GCC10 is not available. So to install GCC10, so it's actually downloading the GCC10 from the repository. So it's like selecting previously unselected package GCC10. Yeah, you can see it's still running. It's rotating. Yeah, done. Now if you want, you can check whether GCC10 is already installed. Now I type it again. Earlier it was not there. Run this code again and find that GCC10 is installed. Now after that, you have to link the CUDA to CUDA 10. So you do this CUDA 10, then you compile this numdevice.c. So here I purposefully added some typos. So that line number 2, line number 4, line number 5, line. So if you want, you can double click on this file. Then we'll see this coming here. Is this hash include? And this is okay now. There is a semicolon missing here. So that whenever you have an error, you can double click and correct the error. So it's automatically saved, and then if I compile again, now it's combine. So a.out should file should come. It's not visible, so you just refresh. So a.out has come. Now you run /a.out. Again, this again purposefully added. Like every command should be preceded by this symbol, exclamatory mark symbol. So this I added. So you get number of devices equal to 0 because you have not changed the runtime. So runtime, you have to change runtime type to GPU. Save. Then you click on /a.out. Oh, I have to run it again. So I change the runtime again means you have to run it again. So you're not able to locate. So add this tool chain, this write file. Now to install GCC. Still running. So installation is down. The arrow is not now. It's arrow. The rotation has stopped. So where is GCC 10? You find GCC 10. Then you link this CUDA to CUDA 10. Then you compile it. So the numdevice.c is again the old file. So include semicolon. Then compile it again. Then include now the refresh a.out has come. Now you /a.out. Now number of days is 1. So just purposely added this type of mistake so that when you do the lab, you are also familiar that such errors can be easily recovered or easily resolved. Then I'm writing first.c here. Print of percentage d percentage a00 b00 c00. So it's multiplication. So I've written first.c. So first.d is now available. Combine with this command line argument, and you get first should come here. If it is not coming, you just refresh. First is available here now. /first shows 571 into 220 should be equal to this value. So, but we are not sure whether execution has happened on GPU. For that, you have to use nvprof command. So you see that GPU activities are there, like copying data from host to device, etc. are there. Then CUDA malloc, those things are there. So like this mentioned by data map to A, B, C. AB. Map to AB means A and B are copied to CPU. And after the parallel loop, you are mapping data to C. C is copied from GPU to CPU. From means copy from GPU to CPU. To means copy to GPU. So copy to GPU from CPU. So these things are happening like OpenMP CPI host to device, OpenMP CPI. These things are happening. So you find that there is execution happening and you're using GPU. For the exact details of nvprof, we will skip for the time being. And, so